Hello guys, welcome to MindMajix, and in this special session our trainer will explain everything you need to know about the Informatica MDM. Before beginning the session, let's look at the topics you will cover in this video. We shall start with base object table and their loading part, and continue with staging tables, external match table, raw tables, landing table section, support tables, metadata tables, mapping, batch process flow, source systems, and end this session with XREF tables. Please check the caption to jump between the topics. If you are new to the MindMajix channel, please subscribe and press the bell icon to get quick updates about the new tech tutorials, free webinars, and career-enhancing shots from working professionals. Like and share the video with your friends and career aspirants. Without any further delay, let's start the video.
Today we'll discuss more about deep on base object tables and their loading part. So we discuss about the batch process flow. So before going to discuss the batch process flow, like I'll show you the base objects and their associated in support tables and landing tables and stage tables. Okay, let's share the screen. Okay, so just consider one existing base object table. So here we have one base object table, which is CBO Party Hr. Let's run this table and see what type of data it has and type of columns, data type columns. Okay. So here base object Party Hr. Let's consider this. This is the base object table which we have created in the MDM Hub application using under the model workbench. So before, like for every time, like in order to work on any workbench, first we have to take the write log, go to write log section and acquire log. So then we can able to create the tables, create tables or drop tables. So if we observe, if we click on the base object section here, we see plus symbol and minus symbol. Minus symbol is for removing of the objects and plus symbol is for creation of new objects. Okay, so let's discuss about the existing base object, and we'll try to create like a new base object and then see the associated support tables. Okay, consider the base object Party Hr, which is a display name, and the physical name is CBO Party Hr. Okay, here the physical name length should not be greater than 24 characters. Okay, if it is greater than 24 characters, it will not accept, and this is applicable to every object which we create in Informatica MDM Hub. Okay, and we'll see the table at the database level. Okay, let's connect to the CMX ORS schema. This is Oracle database 11 version we are using, 11G. Okay. We have connected to the database. Okay, so already there is an existing data is available in this table, which is CBO Party Hr. Okay, so for this table, as I explained in the first session, for every base object table, we have 14 associated infrastructure or in support tables. Let's see at the database level. Okay, for this CBO Party Hr, how many tables are exist. So for this base object table, we have cross-reference table, which we call in our day-to-day project activities as XREF table. and history table. So let's go to CBO Party RJ. See here, we have couple of support tables. We call as a infrastructure tables or support tables. We, as I said, that cross-reference table, which we call as XREF table. For every base object, we have one XREF table, and it is very important one. Like in the coming classes, I will explain more on cross-reference table. And other tables we have, among that match table. Here the match records information will be stored, and we have HMRG table. Here we have that merge details of the records will be present, and we have a dirty table. So dirty table gets populated whenever a new record inserted into the base object table. So that corresponding row ID object will be stored in this dirty table, and like that we have CTL table, which stores the trust score informations, and we have VCT table, which stores the validation information, validation columns details, and we have VXOR, which stores the validation column details of cross-reference table, and we have EMI EMO tables. This is external match input, external match output table, and we'll see this later. Okay. And other table, STRP table. This table is contains tokens data. So whenever we go for fuzzy type matching, then only this table gets populated, otherwise it will be empty. And there are other tables are there, history tables. Right now we haven't configured history configuration for this base object party RJ table. That's why we don't have history tables. Otherwise we would have 4 more tables. If we count this like 1 2 3 4 5 6 7 8 9 10. So if we enable history, then we can see 4 more tables. Okay. And let's see in detail about this base object table, what type of the properties it holds and those details. So as I just now as explained, whenever we enable this, the history tables will get supportive history tables will get created automatically. And we have advanced section. So here we configure the base object properties. So here we have tokenization ratio 60%. So here's nothing but whenever the records loaded into the base object, okay, if there are changes more than 60% to the existing records and new records are present, then complete retokenization will be performed. So if it crosses the greater than 60% threshold, then MDM will go for complete tokenization ratio on that base object table. Suppose for example, we have 1 million records in our base object table, and we got updates or inserts, new inserts to 600k records, more than 600k records, then MDM will go for complete tokenization. And we'll discuss more about tokenization when we come into the fuzzy match strategy. And here we have the option allow constraints to be disabled. So whenever we create a base object table, at the back end there will be some indexes and check constraints will be created. So during the load process, Informatica will automatically disable those constraints, and once after the load process, it's automatically enable those constraints like indexes. Okay, check constraints. So why this feature has been implemented here is to improve the speed of operation for loading part. Okay, and here we have load batch size. So here like one during the one batch load process, like how many records a base object table should get loaded. Suppose if we keep 1,000 only, then at a time only 1,000 records will be loaded into the base object table. Okay. Again, this value has been implemented for performance improvement. And max elapsed match minutes are there, 20 minutes. By default, we have 20 minutes. Okay. So once the data loads into the base object table, we have to run match job. So MDM identifies the potential match records or else duplicate records, and then it gets merges into single record. So how much time MDM application should spend on a particular table here. So for sometimes we increase this time period. So mainly for the main driver table, which we call party table, for that, like we increase the time period. Suppose like 1,000 minutes or 3,000 minutes, 500 minutes. Again, depends upon the data volume which we process. And parallel degree, so it's like based upon the available of threads and CPUs available, we can increase this value. And requeue on parent match. So whenever the parent records gets matched, so we know that like in a database environment, in all the tables are interrelated. Suppose like we have parent and child tables are there. So whenever the parent records gets merged, associated child, or what should happen to the child records? That's what, like whenever we click S, then what will happen? That whenever the parent records gets merged, the child records will automatically go into the match queue. So whenever the match process has been run on the child table, the records gets matched and generates match tokens on load. Again, this is like a performance improvement, like it's developer wish, or it's like a business requirement wish, like we can enable the match tokens on load. Generally, we don't enable this until unless if you don't have any dependency on other child tables, then only we can enable this one. And match flag audit table. So we have we have some audit tables at the back end. So if we enable this flag, then what will happen to during the load process to a particular record, that everything will be detail will be stored. And we have API lock interval as a default 30 seconds. So here, like during the batch process, like we can API tools also can communicate with the MDM hub application. Suppose like for an example, one record is being processed through batch process, and that same record has to be processed by API tool. So at the time, if batch process log that record first time, then it allocates 300 seconds. Post 300 seconds, even if the record does not process, then it release that record and applies, and the record will be logged for API processing, and it holds for 30 seconds. And we have enabled state management. This state management is like to put the records in active state or inactive state or pending state. Okay, again, we'll discuss more on this on the coming sessions. And we have enabled history for cross-reference promotion. Again, this is for history and information. And we have lookup indicator. So we can so in the MDM we have base object tables and lookup base object tables. So if a table should act as a lookup table, we then we enable this indicator. And the last option is like base object style, med style, or link style. So link style, what will happen? The records will not get physically merged, whereas here in med style, the records will get physically merged. Okay, again, it's a business requirement. These are the details about the base object. And let's see the column. Let's see at the columns level. Okay, so here there are some user defined columns are there. From full name to Vivo class code, we have user defined columns, and their associated data type, length, price, and scale. And we have some properties are there. I'll explain later. And we have one row AD object column is there. So this column is the primary key column. So here that's why we have key symbol is there. This is the primary key column, and it is the auto populated, auto incremented value. So user, like we don't touch that row ID object, or else like we don't load the row ID object with user defined value. It's MDM issue. So MDM will take care of that data loading part. And we have the option show systems columns. So whenever we check this one, like there are 13 system columns are there. Okay. Those are the delete indicator. So if you observe here, system columns have been noted with one log symbol. So by default, these columns will get created whenever we create a base object in the MDM Hub application. Okay. Delete indicator, consolidation indicator, lost update date, updated by create date, creator, content metadata, that indicator, interaction ID, hub state indicator, lost row ID system, that indicator, deleted by deleted date. All these are system defined columns, and these system defined columns will be automatically published by MDM itself. So user cannot have any control over the system defined columns. And in the system defined columns, we have few columns very important for our day-to-day activities during the data processing and even for the data analysis. Among that, one is consolidation indicator, last updated date, and hub state indicator, and the PK primary key column row ID object. These are the very important columns which we need to know. Then only we can understand how the data loads in the MDM. Okay. We'll discuss on these columns during our data loading process. And here one more section, XREF only. By default, cross-reference table will be created. So user does not have control over the cross-reference table. So whenever we create any base object table, cross-reference table will be created automatically. And here we have history option. As of now, we haven't enabled the history. That's why the history tables have not been created. And we have match and match setup section is there. Here we set up the match and match rules. Okay. And we have validation rules setup is there for validation of the columns. And we have message trigger setup is there for near real-time implementation. And we have relationship section is there. So how this base object party table has been related with other tables. Okay. One to many, one to one, and again it depends upon the business requirements. Here we have two sections are the table references. Table is referenced by. Table is referenced by means this party table will be acts as parent table. Okay. And table reference means this table is being referenced with other tables. So other tables, nothing but any lookup tables, or this might be this table acts as a child table to other parent table. So here we have a BO class code, RBO BO class. This is one lookup table, and lookup party type is one lookup table, and lookup gender is one of the lookup table. And this consolidation indicator row ID system is by default will be created. It's internal to the MDM. So if you see here, we see the differences. So here we have associated index and type virtually the relationship has been created. Okay. So here, whenever we create a base object table and we define the relationships, that relationship will be virtual to the MDM hub. Means at the database level, there will not be any relationship will be defined. All those relations will be defined at the MDM hub level only. Means these are virtual level, not the physical level. I'll show you those differences also. And after that, we have staging table section is there. So for every base object, if there are four source systems are contributing the data to this base object table, we'll have four staging tables. Okay. Right now here, two source systems are contributing to this base object table. That's why we have two source systems. And we have external match and table. So again, this is like for external match purpose. Suppose like we have some data existing in the base object, but we don't want to disturb the data, but we have some data available with us. We have to check that whether the data is matching with the existing data of base object table. So in that case, we'll provide the data to these tables, and then we perform the match and match process. So whichever the records get matched, the data will be populated into this table. And we have custom index setup is there. So in case to improve the performance readability of an base object table, so we can create custom indexes. So these are the details about the base object table, and we have the staging table section is there, and this is also very important one. And here we have some properties are there. So column, let's go to the column section. So here also we have some system columns. If you see here, stage table does not have any primary key, and it has 16 system columns and 12 regular columns. Okay. Here in the stage tables, we don't create any column. Whichever the columns we create at the base object table, that means here in this section, those columns will be used here. Okay, we'll get the check symbol. So it's our wish, we can use this column or we cannot use this column. Okay. And we have system columns. Let's see what type of system columns it present. Again, we have PK source object. It is one of the system column. So if we see the difference in the icon for the system columns, we have some log symbol is there. That means these are the system columns. It can be handled by MDM itself. Okay. And so in these system columns, we have PK source object. This is very important column. And this column data type length is varchar and length is 255. So it holds varchar information, and this PK source object value should be unique to the particular staging table. Okay. For this particular staging table, this PK source object should be unique. Then only it accepts the data. Otherwise, the data will be rejected. So here the PK source object should be unique, means at that particular instance of time. Okay. And let's see the landing table section also. And before going to the landing table section, we have some other settings options are there. So here we have options: preserve and edit trial in the raw table and enable delta detection. So in MDM, how can we load the data is we can load the data using batch process. So suppose like yesterday we loaded 100 records. Today we got a few more records. So we don't load the data, full data load. Suppose like yesterday we have loaded 100 records and today we got to 10 more new data. Then in MDM, there is some options. There are features are there, like we can load all the yesterday's records and today's records, or else we can load the only the incremental load data. So for incremental load, it's up to the ETL developer or ETL team to identify the incremental data and pass the data to the MDM. Or else, like if we don't have incremental data, all data we are getting from the source, then we have to enable this delta detection, and then MDM will be identify those changed data or new records, or else the soft deleted records, and it loads into the MDM database. Okay, again it is an overhead to the MDM application, because it has to identify which records have been newly inserted and which records have got updated, and this it's an like extra processing for MDM. So most of the projects will not go by delta detection will go by incremental load only. And here we have a preserve audit trail in the raw table. So suppose like yesterday we have loaded 100 records, today we have loaded 150 records, whether it could be new records or updated records. And suppose like on a particular day something happened to to a record, and in order to backtrace those records, so like it sometimes it may be possible to contact the source system. Suppose like if you don't have like from the source system, we like there is a data is not available, so at the time what we can do is like we can go for our audit trail records. So here we can mention how many loads data, like suppose if I mention number 10, so 10 loads of information will be stored in the MDM, or else we can represent the time duration. So how many months of data we can store. Suppose like if I may mention one, means like 1 month of the data will be stored in the raw table, or else if it is quarter. So it's like again depends upon the business requirement. So these options will be enabled or else will be used in the projects as per the business requirements. For most of the projects, we don't implement these two sections because it's an overhead to the MDM hub application, and at the same time like it's an extra memory usage, unnecessary storage of data, which is not most of the time not useful for us. Suppose like if you take in a financial institution and every day we get thousands of records, updates or new inserts. So in a day, like 4 times batch processing will be performed. Just think of that, like for every base object table, 10,000 records, suppose consider 10,000 records or updates or inserts are coming, and these 10,000 records should be loaded in one of the raw tables. And like that, like if you mention 10 loads, is 10 into 10,000, like 100K records will be stored for every base object table. So like it's not recommended until unless it's an business requirement to track and each and every record. Otherwise, like we don't implement this. And these are the raw tables. Okay. For every stage table, there would be one raw table listed with the columns. Even we don't mention these columns, we don't create these columns, all these columns will be used whichever created at the base object table level, and we have some system columns are there. The system columns are version sequence, PK source object, online indicator, row ID object. All these are handled by Informatica MDM. Okay, let's see the landing table section. Landing table section. So here we have landing table section. As I said in previous session, landing table is nothing but an entry point or entry gate to the Informatica MDM. Let's check any one landing table. Let's consider the landing table Party Hr. So this is the display name. This is the fiscal name. Again, fiscal name limitation is it should not be greater than 24 characters. And here we have option contains full data set. So if you enable this option, okay, at the stage tables level, we can implement the delta detection or audit trail information. Okay, so if we don't have this option enable, we cannot implement the delta detection option properly. Okay, so here we are specifying to the MDM application that whatever the data comes to this landing table, it contains full data set, means like previous data, 10 days back data, and the latest today's data. So it's up to the MDM to identify the incremental data, new records, or deleted records, updated records. Okay. So generally we don't enable this one until unless it is a business requirement. And the columns here, we have to create the columns, or else we can import those columns using import section. We connect to the database and we can import from the base object. that too, those columns are user defined columns. And we have one system column is there, which is row ID source. Again, the notation is different. Okay, again, it is an identity column, auto increment column, which will be handled by MDM. So we don't consider this column for our data loads. Okay, and let's see the let's create one new table and see at the database level. So here I want to create one new table. So click plus symbol, one new base object table, click plus symbol, and here we have the option drop down base object or landing table. So I want to create base object table. We can create base object without creation of landing table also. Nothing will happen. Landing table and base object are interdependent. Okay. No dependency will exist. Display name, we can create like we can use our own display name, but as per the project notations, like so to show the difference whether at the database level. So in the database level, we see only the physical name, right? We don't see the display name. So to represent, to notate the difference, what is the base object table and what is landing table, what is stage table. So for base object, generally we go with base object and it's any name. Let's see, party. Okay. And physical name will be automatically gets populated. So here the physical name will be greater than 24 characters. 1, 2, 3. Oh, it is not greater than 24 characters. That's why it has been created. So we are saving the table. It takes a couple of minutes for first instance. So here and one more thing I have to discuss. So we should not create the tables or we should not create new columns for an existing base object at the database level. If create the columns or table at the database level, MDM will not detect that table. So here, let's see what, okay, we have created our new table and let's see the columns. There are no user defined columns, only system columns are available. Okay. And this is the table name which we have implemented. Okay. And let's see the associated support tables for this. Let's refresh. See base object. Yeah, base object party Hr. So this is our main table, and if you see the columns, only the system defined columns only present. Okay, and here the column should be defined from MDM hub level only. If we define the columns from database level, that columns will not be detected. Let's see if I try to create one new column through the database. Let's see what will happen. Okay. 1 plus symbol. Okay, column 1, right? Let's see this one name. Okay, and it's varchar of 50 and okay, click OK. One new column has been created. If you look at the MDM Hub database site, let's refresh the schema. Refreshing. Okay, well, refresh one more time. Okay, And if you go to the column section, we don't see any of the user defined column name. Okay, that's the main drawback. Why it will not detect the column is like whichever the object we create at the MDM Hub application, all those details will be stored in the metadata tables, metadata database. Those like C repos, column C repos tables. There should be an entry. Let's see that also. So we have C repos tables are there. Select star from select star from C underscore C repos underscore columns. Let's run this table. So here we have table name is there. Okay, let's where table name equal to where table underscore name equal to C underscore base underscore object underscore party underscore HR. If you run this, we see which are the columns associated to the table. So only the system columns whichever created by MDM Hub. When if you see the column names, there is no name column. Okay, that's the major difference. So all the information will be stored at the metadata tables. So there should be an entry in the metadata tables. So it's not recommended to make changes to the metadata tables. Whenever we make those changes to metadata tables, that every metadata table has been linked with other metadata tables. So it's pretty hard to crack um, where we have to add that record. So it's not recommended to make changes to the metadata tables. So if we make changes to the metadata tables, there may be chances of corrupted data. So we get the wrong results. And sometimes like even the entire database will go in invalid state, ORS. So it's not recommended. So let's see like here, remove the record, remove the column, name column, and we have removed the columns. Let's see, or we have any data constraints are there. Right now we don't have any constraints, and see indexes. So we don't have any indexes. So here we have one constraint is there. Okay, primary key and indexes. By default, we have two indexes are there. Consolidation, row ID object. Okay. So these two are created automatically. Click OK. Then the column will be removed. Let's see let's refresh here and simply create new column. Click plus symbol, create new column, name, and physical name will be automatically gets created, and varchar 50. Click there. It issues the DDL statement at backend, and the new column will be created. A new column will be created. If you run the database table, see the metadata table, metadata table. The name column will be created over here. Yeah, the name column, user defined column, which is an user defined column, and so once we define here, let's see at the database level also. Just refresh this. Yeah, name column has been created. Okay, that's the difference. So in MDM, we should not make any changes directly on database level, whether it's insertion of the record, inserting a record into the database, or else altering a table or creation of new table. We should not perform these things directly on the database. Everything should be performed. Even if you want to insert any new record, we should perform through MDM hub application only. We should not allow, like, otherwise that record will not be detected from MDM application. Okay, and let's see the associated tables, support tables. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tables have been created. Okay, we don't have history tables. Let's see what will happen if we enable the history. Click save. So we are enabled history for this base object. Yeah, we have saved. Let's refresh it, table section, and see how many tables will be created. Okay. If you see here, the table count has been increased. We have HXREF, history of across reference, history of validation table, history of trust table. So 4 new tables have been added. Okay, and these are the 14 tables which are very prominent to the MDM hub application. And whenever we insert a new record, these 14 support tables also gets reflected. So suppose if we insert any new record to a base object table, at the back end, 14 support tables will also get impacted. That's why I said that we should not make any changes to a record at directly on database level. So if you make changes directly on database level, those changes will not get reflected in these tables. So that there may be of chances data corruption will happen and we see the wrong results. That's why it is not advisable to make any changes directly at the database level. Okay. This is brief, detail about the base object, and let's dig into the stage tables. So here we create stage table as per the source systems. Suppose consider this party HR table has been loaded by, like, will be loaded by 4 source systems, or else like 3 source systems. Then we have to create 3 stage tables. So before going to create these stage tables, the corresponding source system should be available in this MDM section. So how can we get to know that source system is available or not? Go to the systems and trust section. So here systems are there. So here we have these many source systems are available. SFA, product, MLO, or all these source systems are like simply the naming of a source system. That's it. Like, we don't have any connection parameter over here, nothing. MDM will not interact with other source systems directly. It interacts through landing tables only. So the landing tables gets loaded by these source systems, and we segregate those data into corresponding stage tables. So we can acquire lock and right click, add source systems. So we can add new source system like that. Simply will represent the name of that source system. So right now we have MLO, CKR, SFA. So let's use the existing source systems. Go to schema, staging table. Suppose consider like this party HR base object table will be loaded by 3 source systems. So CKR, that's for the identification purpose. I'll represent the notation. Stage CKR Party Hr, and this table has been created. And here we have one user defined column, so we can use that column. And so if you observe over here, if I remove this C underscore, by default we'll get that. See, even if I try to remove that, by default we are getting C underscore. So for the base object or stage table, anything for a table section, C underscore would be the common one, and it's internal to the Informatica MDM. So every object, every table, user defined table will be started with C underscore by default. Okay, we don't have control with that. And here we have preserved source system keys. Suppose like we are getting the unique source system key values from the source. So then only we enable this one. Otherwise we disable that one. And we have cell update option is there. Cell update is nothing but suppose any of the we have user defined column. So if there is an update to this particular column only, then Informatica MDM will make an update. Otherwise it will not make an update whenever we enable this option. If we don't enable this option, it simply takes the reference of last updated date, and if there is any change in last update date, then that entire record will get updated. Otherwise the record will not get updated. If we enable this one, whichever the columns or needs update, that column will get updated automatically on based upon the PK source object key value. Click OK. Then one stage table will be created automatically. Okay. And let's create one more stage table. Suppose we have another source system. Suppose consider MLO and create stage MLO Party Hr. And if I mention something like here, let's see. Okay. Click OK. See here, the physical name of the table cannot exceed 24 characters. So it's applicable to the entire MDM hub application. So any object should not be greater than 24 characters. Let's remove this. Click OK. One more stage table has been created. We have created 2 stage tables, and let's see the columns level. Okay. If you observe here, settings option has been disabled. I'll let you know why it has been disabled. And we have the column section. Okay. So why the setting section has been disabled is we haven't configured any mappings on this, but for this stage tables. That means like we haven't configured the connection of landing table to the stage tables, means how the data flows from landing table to stage table. Okay, so if we can create the mapping, then here the settings option will be enabled. Okay, so let's create one landing table. For our notation purpose, I am using landing party Hr. Click OK. Okay, one landing table has been created, landing party Hr. So by default contains full data set will be enabled. So we can remove this if we load with incremental data load. Okay. And the columns. So here we have to create two new columns. One is for name, which we have defined at the base object table level, name, and one more column for source system. So we have to segregate the records, right, from which source system we are getting the data. Source system. The source system column. So in this column, we store the values, whether it is CKR or MLO. Okay. Click save. Then one landing table will be created automatically. And let's go to the mapping section. We'll create one mapping. Add mapping. Let's see, map CKR Party Hr. And select the landing table. Landing Party Hr. And the stage table. Stage CKR Party Hr. Click OK. And one mapping will be created automatically. And the backend mapping will be created automatically. See, one mapping has been created. Then we have to map the ports between landing table and stage table. So we'll map the ports. Okay. So these are the system defined columns and we don't map the columns. MDM will populate those fields automatically. And we have to connect one more column, which is PK source object. Okay, we'll connect this PK source object. Okay, we use one function which will concatenate the name and source system. Concatenate operator. The constant. So concatenate for the difference between the name and source system. Just I'm using one constant function, and we have used concatenate operator. Connect to the PK source object. Okay, and we have query parameters of it. So how could MDM loads only the CKR source system data? So we have to filter out that data, right? So go to query parameters, enable condition, SRC system, SRC system equal to CKR. This is just filter condition, wait clause. Validate, okay, executed without error, click save. Then the data flows from landing table to this particular source system stage table, CKR source system stage table. Now see the differences at the base object table level. Okay, go to the schema section, go to the base object, base object Party Hr. Go to the stage table CKR. Earlier, the settings were disabled. Now it has been enabled. Okay, that's the difference. If you observe for the stage table, we don't have that option has been enabled. Okay, these are the main differences. Now what? Before going to load the data into the base object table, let's see some properties. Okay, and now I'm sharing the one PPT. Okay, so here the batch process flow, how to load the data. So we are getting the data from source systems and we are loading the data to the landing tables. So this landing process section will be handled by ETL team and the data gets loaded into the landing tables. Once the data loads into the landing tables, we have stage jobs are there, which will be configured through third-party schedulers. And these stage jobs will be triggered based upon the frequency and the if you have any cleanse functions are applicable, so that data passed through this cleanse functions. So in our mapping we have used concatenation operator, that is also one cleanse function, so that data will be passed to that cleanse function, otherwise it directly passes and loads into the stage tables. So a stage table will have two tables, raw table and reject table. Raw tables, as I already told that it stores the previous information. It's for audit trail purpose. And reject table. So whenever there is an rejections happen to that stage tables, then that information will be stored into this reject table. So reject tables holds the data. Suppose if there are any duplicate PK source object values comes to the stage table, then the records will get rejected, or else proper lookups will not present, then the stage table data will get rejected, or else the data which we are getting from the source for future date timestamp. Suppose last updated date has some future date values, then straight away the record get rejected. Okay, and the load job. So once the data loads into the stage tables, we have third-party schedulers which runs the load jobs, and the load job loads the data into the base object table. Okay, so here we have cross-reference table and other system tables and reject tables. Here the reject table and the reject table both are same. Okay, and even at the base object level also, if there is a mismatch in lookup, then also the data gets rejected if there is no match in lookup tables. And we have cross-reference tables. This cross-reference table loads during the base object load only. So suppose here what type of the data cross-reference table holds is like the data which present in the base object, same data present in the cross-reference table. Here the difference is base object data holds the golden copy record or master copy record, whereas cross-reference holds the data of all source systems. Suppose a base object gets data from 3 source systems, but that base object contains the golden copy, right? Golden copy is nothing but merged data, single best version group data. Only one record will be present for that associated customer. But whereas in XREF table, the data present for that respect to 3 source systems. Okay. Here the XREF table contains the all source system data, whereas the base object contains the golden copy record. Okay. So based upon these 3 source system data, base object data will get reflected based upon match and match process. Whereas in XREF table, it contains all details, all source system details of that particular customer record or product record. Okay. This is about the batch process flow, and the rest is different one. Okay. So I explained you everything, like how can we create the base object table and everything in the representation. This is sample data model. Okay. So in any of the projects it will be implemented. these are the sample data model and how the stage tables have been configured to the target base object tables. The data flow. Here, how the data flows. These are the landing tables and associated stage tables. So for this customer table has 5 stage tables and then loading into the customer table. Suppose like, and so landing process, that is landing process, and the stage process is this one as I explained, and we have load process. So here are some key points are there in landing table. So as I said, that entry point of the source data into MDM hub, no constraints or referential integrity. We have seen that there are no primary key columns constraints in like during the creation of landing table, and how the landing table gets like ETL process or SQL system, PLSQL store system, or any online system like any JavaScript, we can load the data into the landing tables. Okay. Important columns are like last update date, and we can provide any of source key, like we can create the custom source key value within the landing table. Like during the mapping creation, I have connected a pk source object value by concatenating the name and source system, right? So, like similar to that within the landing table itself, like we can create one custom column and we create one key value which can be directly connect to the pk source object. Contains full data set property. As I said, like whether it's full data set from coming from the source system. If selected true, then true. If not selected, then false. Useful for delta detection process during stage load. So if contains full data set has been enabled, then we'll get the feature to enable delta detection. Okay. So base object stores the best version truth. Okay. And each base object has one cross-reference table, underlying cross-reference table, and maintained by the MDM table. So we don't load data to the cross-reference table. We load only data to the base object table. All the support tables will be loaded automatically by MDM. So in cross-reference table, we have few important columns are there: row ID XREF, row ID system, PK source object, row ID object last updated, source LDT. So row ID XREF is the unique value to that cross-reference table, whereas row ID object is the unique value for the base object table. And row ID system, as I said, that a cross-reference table holds the source system records. Suppose a base object gets data from 3 source system, the cross-reference table holds the records from 3 source system. So for that, like from which source system that record has been inserted, so this column value holds that. And PK source object, PK source object is nothing but unique value to the particular stage table. Okay, so every stage table has one unique key value. That value is PK source object. And row ID object, so like every base object has associated XREF table, right? And it has some golden copy records. So like how can we identify like that golden copy record has been created with from which source system? Because so through row ID object we can identify that records. And last update date, when those records have been last updated, and source LUD during the creation of the record from the source system, this value gets updated. Post on later incremental load for data updation, only last updated date value will be updated for that particular record, source system record. Okay. And we have stage table. As I said, stage table PK source object is primary key for the source system, source ID, which is internal to the MDM, and it will be loaded automatically by MDM and last update date. Okay. Here the source stage table represents like belongs to one specific source system. So here we have to remember few particular things. So we can associate one landing table to multiple staging tables. So here, one landing table to one stage table, one landing table to multiple stage tables. Whereas multiple landing tables cannot be associated to single stage table. And One stage table can be associated to one base object. Multiple staging tables can be associated to one base object. Okay. Whereas one stage of table cannot be associated with multiple base object. We know why. Like for under the base object only we can create stage tables. Okay. Stage tables are not independent to the base object. Okay. Stage tables are independent to the base object. That's why like one stage table cannot be associated to different base object tables. Okay. Stage process. So we have to configure the mapping for stage process and cleanse functions as required, and we map the columns. So how we have mapped the columns, and I explained how can we uh, add the functions, everything. Okay, enable condition is similar to the SQL where clause. Enable listings for to get the distinct records. Suppose like maybe landing table contains the duplicate data. So to avoid that, like we can enable distinct function, but make sure like we'll make sure that before loading the data into landing table, we'll remove the duplicate records. Okay, let's see the data loading part. Okay, so here we have created landing table. So let's insert some data into landing table and see how the data flows. Go and connect to the landing table. Just refresh the tables. So, see landing. The landing party Hr. So these are the columns which are available. Let's insert the data. Create one new record. Source ID. This is internal to the MDM, and that it is an identity column. So no need of providing value to that one. And we have to provide the last update date value. So we can provide any one data, provide the future date and name. Let's see my name. And source system, we'll put CKR and new record. And this is from MLO. And one more record. And this is from CKR source system. Just commit these changes. And so we have 3 records. And let's see how can we load the data into the stage tables. Okay. So to load the data into the stage tables, we have to select the batch viewer section. So in the batch viewer section, the jobs will be created automatically. Whenever we create any new mapping, that associated job will be created automatically under the batch viewer section. Whereas in batch group section, we have to create group of the jobs. Okay. Go to the staging section, stage CKR Party Hr. Okay. Right now we haven't created mapping for MLO. That's why we cannot load the data. Means data will not be loaded to the MLO source system of stage table. Execute batch. 2 records will be loaded. Automatically gets identified and 2 records will be loaded. Okay. Like 3 records are available, but only 2 records are loaded because we have enabled filter condition where source system is equal to CKR and the data loaded into the stage table. Let's see the stage table. C stage part CKR Party Hr. C stage Party Hr table, and see the data. Two records have been inserted, and for some of the metadata tables, metadata system defined columns, source row ID, and these columns will be automatically populated. Okay, and PK source object which we have concatenated, and like this has been automatically this has been loaded with the concatenated values. And for stage table, we have three more tables have been created. One is OPL, PRL, raw table, reject table. Reject table I have mentioned you already. What's the usage of reject table? Whenever there is a duplicate record, then the record will be rejected, and we'll see that that thing also. And we have raw table for audit purpose. Right now we haven't configured anything so we will not have any data because we haven't enabled that how many loads of data should be present. We'll look into that also. And PRL table, previous landing table, and OPL table, online previous landing table. These things for delta detection we use. Okay, so we haven't configured delta detection, that's why we don't have data to this one. And let's see how the records will be rejected. Okay, so we have landing table, we have created that three records. Let's create one more record with future date. Okay. So here the date is June 6, 2017, and I have provided June 8th, no, June 2nd, 2017, and I have provided June 8th. And let's see more 4, okay, and CKR. And let's create new record. This is with uh, without the future date. Okay, here it is June 2nd, but I'm taking the timestamp June 1st, and I'm taking the value as Kumar only and CKR. So here we have PK source object is being loaded with name and source system column, right? So already Kumar and CKR data is available. Let's see like whether the record gets rejected or not. Okay, let's commit this one. Rerun the job, execute. We have created two more records. So if you see here, we have one warning symbol. Let's go and see what's happened. So here there is an description completed with two rejected records two. Let's see what's happened to that one. And here we have error description. The date is missing or occurs in the future. Okay, we have provided future timestamp, and we have provided duplicated landing records. Okay, here the PK source object is primary key one, but the data here we have duplicated data. Same data is present. That's why it's not loaded. And see the data in reject table. If you see this, the data section, so the reject information is there. Okay, and let's see for a raw table and OPL table. Okay, let's adjust this timestamp. Right. Commit this one. We'll rerun the, like by enabling the, let's enable the delta detection. CKR at the settings section. We reserve an audit trail. So I'm mentioning the how many loads. Let's say I'll hold only one load of information and enable delta detection. Okay. Detects delta by comparing all columns in the mapping. Okay. Or else detect deltas through date column. Till now we have seen till base object stage table level only. This once we enable this one, this can be seen during the load process of base object only. Okay, we cannot observe this difference while loading the stage table. Okay. Here I am selecting like all columns should be compared. Okay, and let's save this one. So in the landing table section, we'll create one more column for our delta detection enablement. Go to the column section and I'll add one more column, simple like contact. Let's save it and map that contact column also in the mapping. And even we have to create that column at the base object table also. Contact. Let's save it. And link that to here also in stage table. Save it. Now change the mappings. Map the contact column in mapping also. Go to the mapping section. So before going there, here we update the landing table also. We'll update the contact. We have updated contact. Let's see, like, and we'll map that contact column to the contacts. Okay. Now save this and we'll make sure all are unique contact. Okay. Now run the stage job. Okay, we are running that. Let's see what happened. PRL. Order column to be modified must be empty to decrease the position or square. Okay. PRL alter table. PRL table. Okay. Let's like drop the stage table and recreate. So there is an let's go to the stage table section. remove this. Mapping will be created automatically and will be deleted automatically once we drop this stage table. Create the stage table. Hr. Click OK and we'll create quickly one mapping. So we have created mapping. Map CKR Party Hr. Party Hr and select the landing table. Landing Party Hr. Stage CKR Party Hr. Click OK and it'll automate the map the columns, and we have to connect the PK source object. Auto map and source connection is not needed. Enable condition src underscore system equal to CKR and diagram. Let's concatenate the name and contact now. Source system. Source constant. Let's save it. Oh, we have to connect this PK source object. Save it. And let's quickly on query parameters and test. Here we have the test functionality is there. We test like the mapping functionality, how the data will be reflected. If you provide Rohit, test it. So Rohit came like that. And so go to the schema section, base object, staging table area, and configure the loads. Okay. Wizard loads, one load LPwizard, enable data detection by comparing all columns. Please save this and we'll load the data using batch viewer section. Go to batch viewer. Stage CKR Party Hr. Run the job. Okay, again it is identification is not integer not null. Okay, but delta detection for server content. Enter table check modify. Okay, let's check this PRL table. See stays. Stays PRL. Right. indicators. Default number integer. Integer not null. We'll make it as null, not nullable. We'll make it as not nullable on an indicator. So click OK. Let's rerun this. Let's click page. Let's see what data present here. Remove this. Remove this. Remove this. Remove this. Change this. Let's rerun this. Chart from education. Okay. So like let's see we'll remove that delta detection. It's not needed right now. Not part of our course also. We'll disable this. Let's save this. Rerun the job. Rerun the job. Refresh. Okay, it has been loaded. 4 records has been inserted. Let's see. Let's see in the stage section. 4 records have been inserted. Okay, and let's see the data in raw table also. We'll see one data load section data. Okay, and we can load the data to the base object using load functionality. So for every base object, there is associated one entry in the batchware section. So here we have base object party HR entry, and we have load job sections. Okay. We'll load the job. Execute. Refresh. 4 records have been inserted. If we see at the base object section level, CBO party HR. See base object party HR. Okay. So 4 records have been inserted. Okay. This is the data load about the and base object, and we can see the XREF entry also. So here we have XREF entry, and see here the system columns, row ID object, row ID system source LUD, and the hub state indicator, null bitmap indicator, creator, created it. All these system columns have been taken care by MDM itself. These are the user defined columns. And let's see the records. How can we update that? Suppose on a particular day we got an update. We got an update to the existing record. Suppose we got an update to this one. Eight seven four seven instead of 8745. Commit this one. So commit this one. Okay, we have added 8747, and we see that data 8745 was available. Okay. So here during every load operation, all the landing tables and stage tables are truncate and reload. So the landing tables we have to truncate manually, and stage tables will be truncated and reloaded automatically by MDM itself. Quickly run the batch. As right now 5 records are available, so for 5 records are available and 1 record from MLO system, 4 records from CKR source systems. That 4 records are loaded into the stage table. Again, this stage table is every time it's truncate and reload. Okay, now let's run the load job. Okay, before running the load job, so don't get confused that already there are 4 records in stage table, but only 1 record has got updated, and we see that 3 records as a no action. I'll explain on that also. See here. So there are no updates. No record has been updated. So even though there is an update to the one of the column. So why the record has not updated is like here we haven't changed the last update date. If you see here last update date here and the base object XREF table, base object XREF table. Here the source LUD, source last updated at the source LUD. This record 8745 1050 to 45 1050 to 45. Same timestamp is there. So if we change the timestamp over here, suppose I kept it as June 2nd, today's date, commit it and rerun the job. So then it can be identified automatically. Now rerun the job, stage job. So stage job is nothing but data loads from landing to stage table. Okay. 4 records have been inserted in stage table because it is truncate and reload. Load job loads the data from stage table to the respective base object table. Now run. See here, 1 record has been updated, 3 records. There is no action because there is no change to that record to the respective last update date at the landing table level and source LUD of XREF table level. But there is a change at the source LUD level at the XREF table. If you see here, now it is 50 to 45. If you refresh it, that timestamp will get changed automatically. Eight seven four five eight 8747. Let's refresh the entire section here. Yeah, so here we got June 2nd, and instead of 8745 we got 8746. So the XREF has been updated like this. This is the complete picture of loading to the base object table. In next class we can see the match and match section. Thank you.